20.3.6. This is Fourier transform, right? Apply a function, solve the equation, and transform using back and get that one. Yeah, this is an example for solving differential equation using Fourier transform. Then what is that first? Okay. 3.6 is the exercise. And the differential equation is t squared by x squared. As delta k squared d by equals to delta q times delta function. Okay. D and k squared are constant. Q is also constant. Q, and I think so. So all these are constant. So it's just write a k squared d with a string, but doesn't matter. All right. We are going to solve by taking Fourier transform. So, you assume the Fourier transform of phi is whatever that you call it. Phi is what? Capital phi or phi. Then taking each term, so the Fourier transform second derivative, you know that the last time we also talked about it, right? So there's you pull a minus k squared, so minus is positive, so d k squared. This is little k, but this is capital K, and then phi. And the second term is easy, just the same. Right. And the right-hand side is the Fourier transform of delta function. Remember that? What is that? 1/2. 1 over square 2 pi. Yes. Yeah. Not. Yeah. Because this is x not. There's no x minus x because there's exponential function. If and some of you then follow, so you calculate the Fourier transform of delta function. The Fourier transform is multiplied by e. Transform is I think a textbook REK dx, right? You just pull out the zero, and zeros at p is just 1, so it's just 1. So there's so this is the Fourier transform of the delta function. So it's 2 pi. All right. So phi is you can solve it by combine the two and you have q, and combining the coefficient, you have a d outside, and then k squared, small k squared plus delta k squared. Right. And there's a square root of 2 pi. Right. So that's the transform. Now you solve phi by the inverse transform. There's no negative. There's a negative, but when you take a second derivative, you put a minus k squared. That's the property of, yeah. So, yeah. Now, that kind of transform, we saw that before. This is this is Fourier transforms. So what Fourier transform will give you this? So basically, if you want to find the inverse Fourier transform, this will be the inverse Fourier transform. Inverse how to get 1/t t minus 1 t minus inverse Fourier transform, right? And of course, obviously, you can do it by integral, but if you saw the transform, you probably can look that up. I think. Oh yeah, 20.30. Yeah. That is good. More like it. I was looking at the 3D one. That was not one. That is this is the transform of this e to the minus r t. That absolute value t. The transform is equals to again equation like that and either this group is in this group. Okay. To the last step is just to compare the formula with here. So what you don't have is you have this one. So in order to get to that, so so identified K is your alpha, right? K is your alpha. Omega, yes, omega just K. So omega is just K because it's just 1D. Whether you call it omega or K or T, that the text like to do that. So this is K, and so first you want to write it in the form like that. So you have 2K and divided by 2K, right? Now you have 2K and divided by that and this one. So this part is this one, right? And the other the coefficient. So just write back over 2 capital K B. The natural function is this one, so minus K absolute value of right. That could be the answer. Yeah, the textbook include the K in the absolute value, which is fine. This is implicitly assuming K is positive. So when you write K like that, it's the absolute value. These are the absolute value. Okay.